Meticulous. Yes. Methodical. Educated. They were these things. Nothing extreme, like anyone they buried. There were days of mistakes, laziness, and infighting. And there were days, good days, when by anyone's judgment, they would have to be considered clever.
As Australian scientists grapple with climate change and fuel and water shortages, one Brisbane man is sure he has the answer. Free power. He believes it's possible to defy physics.
Has the light gone on for Brisbane's Chas Campbell? Or, as sceptics might wonder, gone out? Forget coal, forget nuclear. Chas reckons he can make free power.
There's lots of engineers who'll scratch their head and say he's mad, but I don't care what they say, I'm not mad.
What Chas says he's done in a small garage in a suburban unit, chipping away on a concept for 3 years, is essentially against the law of physics.
By using a very small portion of electricity, you can generate anything up to 10 times as much free power, and it's clean.
We're talking perpetual motion. A series of wheels driven by an 800-watt electric motor turns a 3,500-watt alternator. It then drives a 2,500-watt circular saw, a drill and lights and a fan.
I can make one of these that'll drive 1,000-watt kVA, 1,000 kVA, I'm sorry, which is 1 megawatt of electricity, and probably use 50 horsepower to do it.
The scientists doubt it.
That if you can get more energy out than you put in, then you can create a perpetual motion machine. So you can build a machine that has infinite amount of energy, and that's simply not fathomable.
It wasn't fathomable either to any of the politicians the one-time builder, now retired pensioner, contacted.
That's okay. That's okay. I don't mind what they say about me.
Chas doesn't want money. He doesn't want to sell his free energy. He just wants governments to know it's there, it's available, and he's sure it can be done. And in a world needing cheaper, cleaner power, he should be commended for trying. Mark Sulo, 10 News.
You want to start talking?
No?
You want to start talking?
Am I what?
Start talking.
Oh, I said I can put another disc right on. You're not filming it yet, are you?
Yeah.
Oh, you are?
Yeah.
Oh, that's okay. Yeah, but that's not going on the camera, is it?
Yeah.
Oh. Well, wait a minute. This is all going to be put together, right? Isn't it?
When you're ready.
Thanks for giving me the opportunity to show you what can be achieved by using one of our natural resources. The CD you are watching is showing how electricity is generated by using an alternator powered by gravity. A small portion, approximately 25% of the electricity it produces, is channeled back through the system, thus creating perpetual motion. If this is of any interest to you or your government, I would love to show you how this is achieved. As the logo on the blue wheel stands for, clean, free power. The demonstration you are watching is using electricity generated with an alternator driven by gravity. clean, free power. Thanks for watching.
Yep. So that just needs. You still need to resources to perfect that.
Well, I just wanted to do this to sort of create a little bit of credibility.
Yep.
Right.
Yep.
Now, if you want to see something interesting, right, around here, there's a set of snooker balls, right? You see them there?
Oh, right. Yep.
Right. Now, if I pull that little pin out of there and drop that boom gate, right? And I take that little socket wrench out of there, and the ball's all rolled forward. Now, if I turn this around, right, until that boom gate is lifted up, one of the balls has gone in there. Now I'm going to stop it in a minute because it generates too much power. Right, now I've got to steady it up. Now, when I let this go, because there's a ball there, and there's a ball there, right, that you can see from the other side there. When I let this go, you can't see it. When I let this go, right, now,
Toss the ball down, please.
Now, that ball will come and see it, it rolled into there.
Yep, get it rolling, Good.
See that ball, it rolled into there? Now, you see, this is where it's not synchronized to perfection, right? Unfortunately, it's not.
That's amazing, Dad. Holy crap!
See, it's not. Now, as these balls come up there, you see, and see, the secret is you've got to keep them going in there. If they don't keep going in there, now as they come up, they come back out.
So they continue to go in there. This will just be continuously.
If they continue, see. Because I built this, as you can see, out of bits of well, not bits, aluminium, PVC, galvanised iron, custom born, and I thought I could perfect this. And as much as I've tried, I haven't been able to perfect it. Right? Things like that happen, right? Because the system is not. It's got to be, but if they
fine-tuned. Yep.
The whole idea is when the ball comes up, see that ball there?
Yep.
It gets just eased down, right?
So it's a relay. This is a relay.
It keeps going around, but you see that shouldn't happen, but it does happen because no matter how hard I try to get this to run as smooth as it may be fun, I couldn't get it going.
Has it ever gone around in one cycle without the balls going?
Yeah.
So the proof of principle is there. It just needs to keep the balls in alignment. That's all.
See, the whole concept.
That's still pretty amazing, Chas.
Why don't I just put that back in there? And I have to lift this up because if it's weighted down and they go backwards, right, this thing here that triggers that switch, right, will come up and hook it and jam it, right? So
it's gone one revolution with all the balls that are meant to do what they've done, and it's just re-energised itself.
Well, the thing is with it, there's always more weight here than there is here.
Oh. Well, I'll just get that one for you.
That's because
There's that one, sir.
See, things like that happen because now one of the reasons that happens is this wheel. No matter how hard I try, you've got movement like that. See that?
Yeah. So it's just the basic materials.
You only if once that happens because the weight's shifting from one side to the other, and you create this.
Oh,
now, these things here are all set up. When that's there, it's supposed to be dead level. When that same thing gets up here, it's supposed to be leaning this way. If it happens to rock and the ball gets pushed the other way, it'll drop back out the same hole.
all you're basically saying, all you need to do is stop this vibration and it's going to work as it's supposed to.
The whole thing has got to be built very professionally. You can't build something like this and expect it to work. the way I've done it. Although I did think I would be able to do
Yeah, so you can feel the vibration on that's very timid. It's not going to hold in place where it's supposed to, but it looks like from what we just seen.
It was a lot of fun and a lot of fucking around.
It's pretty sophisticated, mate.
But the whole thing needs, from scratch, it needs, you know, a stand that's very secure. It needs an axle, like that's just ordinary water pipe that I cut and threaded.
Well, I don't need too many pensioners that have made one of these, Chas, so you've done pretty well, mate.
But you know, it's just something I would have liked to have perfected, because
it doesn't look like it's far off. You just need to mitigate the vibration.
Oh yeah, it's you know, I suppose the old word fine tuning. It needs, but the principle. You know, you use the weight out there to lift the ball here, right? And that ball's never any further than halfway out, right? And they just keep coming around and feed back into there. And they,
so pretty simple system, isn't it?
Because if you
and those relay balls will come back and always keep that weighted. So
yeah, well that's the whole idea. Like if I just let that go, now I'll just show you without steadying it up. You know, now if I just let it go.
One. Okay, that'll come down. Hopefully. And the vibration,
See, it starts to pick up power. Now, this is where you see it's picking up too much power, right?
Oh, right,
Notice down on the man?
Oh,
See, those sort of things are happening, which shouldn't happen. And that's happening because there's movement in the wheel, you understand? And now you see, somewhere along the line we've missed out here somewhere.
There's one stuck in. One stuck in.
There's probably a double one stuck in. And as much as I tried very hard, I would have liked to have had this all working to perfection for you before you come out. But as I've said all the time, this is a joke because it's useless unless you can create centrifugal force.
It still doesn't look like it's far off from being perfected though, Chas.
No, but it's not perfected, and that's what it's all about. You know, it's not. The principle. But
the principle's there,
But it was just something I wanted to do, and I done it.
I mean, unless you could see these balls, but go into their sockets and this thing not work, you can't really assume that this is going to do what it's going to do.
Well, the thing is, it's just, for me, they're all out there. Arrows do all men, I know when the whole set of balls are down. That's why I put the carpet around. I've got six balls bouncing on the concrete, right? So I had it on this cardboard cart and stuff like that. But you know, it's something I wanted to do, and I've done it, and I enjoy doing it. Right? Enjoyed every minute of it. It's very frustrating at times, because every time you want to change something, you've got to start pulling things to pieces. But it's just so simple. The ball comes down, he's sitting in there, and he just gets left behind. You know?
That's still amazing, right? Just to be able to reproduce this yourself in your own garage.
It just goes through there, and that little boom gate lets it fall in. But because of the movement, and it's not, you know.
The vibration of that, because it's only look, it's really timid tin, isn't it?
Oh yeah.
So, I mean, I can see from the system, having seen one ball come and return.
But that's how all of this. That's how all of this come about, because I wanted to create energy from something that just kept turning around, right? So the only way you can do that is build up speed. Because you see, this is where you've got to be careful. If there's no balls coming up the other side, and it throws everything out. Now there's two balls in there pulling the wheel down, but I'm holding it so it won't go down. Now that first ball is getting close to being lifted off. So now I'm going to put the third ball in and let it go, right? Now you see it hasn't picked up too much speed. You see what I mean? If you just let it go willy-nilly, it'll go berserk. Now there's no more balls coming in it, so there's no more power here, right? See,
if there was continual balls going in there,
the whole thing is you've got to keep it all as even as you can, so there's no pulsating of the weights and the, you know, it's See that? As it comes up. Now there'll be one coming up behind it if you want to get in. There it is. Can you see that one?
Yep. Yep.
Right? See, they have to come out. They have no alternative but to go out. There's a third one coming up from behind them. So I'll just lift one of these balls off, right? Yep. Now I won't take that grid out of there, and I'll take 3 balls in my hand. Right, now you can stand here and watch this side, and I'll just let that ball, I'll just move this over to say here, now it's completely disengaged. Now that ball will automatically just roll over and lean against there. Now one of the secrets is that it must roll over and go into there. See how that just rolled itself into there?
Into the pipe.
Yeah, and away it goes, because that's on a slope. When it goes around that side, and then you see the next one is tripped, and it rolls in. See? And when it runs around, the next one is tripped. By this time, you see your wheel's picking up speed. And by this time, you see the first one that went in is over here, and he's let through. Now you see that one didn't go right. You see what I mean?
And so it's lost its timing, and therefore the wheel's slowing down.
Well, it's no more balls are going in here. Right?
And the weight's off it. Yep.
The weight's off it. Right? Now you see what I'm going. When that triggers that, see that? That's the next one go in, and on it'll go, and it'll let the next one go in. Now every time it does that, that's important. That part of it's very important, because if you don't maintain that weight over there, the whole thing will break down.
Yeah.
Now while it's maintaining the weight there, now you see 2 balls went in there then, so that throws it right out.
Because what's happening basically is, if we get take a side view of this machine, we'll find we can actually rock this back and forth.
By the weight of the ball moving from one side to another, it creates, no matter how hard I try to stop it, this system has to be made so
so probably like a more compact but heavier version.
No, well, where I made the mistake, I thought that I could make a timber frame, which in itself, you see that?
Is unstable.
Is unstable. I thought I could cut this centrepiece out of timber and put it on. I thought if I braced it up. Yep. But you see, you can't brace from one side of the wheel to the other except on the perimeter. Yep. Right? Okay. Now, as hard as I try to stop any side movement or anything like that, I can't. And so, this little system down here, it's very simple. It's like a little boom gate, and as this wheel goes round, it lifts that roller up, it allows the ball, it only lifts that boom gate that much. But by lifting that, the boom is right in the middle of the ball. The minute it's moved, the ball rolls underneath it. The ball pushes it up. Someone coming?
Just the guy on the bike going past.
Oh. So the whole idea is, and when the balls come up here, you see, it's just, they're just eased out. They've got nowhere else to go.
Yep. So they're bent.
But there's 2 balls. See, there's a ball left in there.
Oh, okay.
See, that was the one that 2 balls went in, right?
Yep.
Now that ball will drop out the other side. Which it comes around here. Now you watch this. You see, when that gets lifted, it lets the ball roll over and it drops into there.
Yep.
Now all of these things have got to be timed to perfection, so as you don't get any unevenness in the momentum.
Yeah.
Right. And if you keep that, the momentum and the weight. There's one that didn't come out properly. That does happen occasionally. Just keep going around in a square from one side to the other and down, right? Yep. So it's a simple theory, but it's got to, the important thing is with a system like this, it's got to be. Now, if I was building it again, if I had the money, and I've always got the desire to do these things, but if I had a few $1,000s to spend on this, I would have a beautiful aluminium frame made, I would have an axle made, not screwed together with bits of aluminium. I would have an axle made that was, absolutely Mickey Mouse, as I say, right? Now, and then that's the most important. Then you build the rest of it around that, right? You start to build the rest of it. Now, the reason this tubing is out here, I thought I may have to brace these. That's why the tubing, but I thought if I do that, that's the fastest moving part of it, out here. So if I can cover this metal, it's a lot easier to move a piece of tube through the atmosphere than it is a square frame, right? Yep. So these are the sorts of things I tried to sort of, on this wheel, I tried to make better than what I'd done before. But it just, see, those balls should roll through and all stay out this side like that. You see how they're moving backwards and forwards?
Oh, yeah, because of the instability of the wheel.
Yeah, because, see, hopefully, you see, it would just roll through and leave it stay out there, right? See, now they're starting to come, now they're starting to come back up. They're starting to come back up.
Yep.
Roll out the top.
No, the concept's working quite well. It just needs some refinement.
It needs fine tuning. I think. Yeah. But before it could be fine tuned to perfection, it's got to be built in such a way that you take all this movement, sideways movement, out of it. The whole thing has got to be built so as it's extremely rigid. And if it was extremely rigid and it's out of the elements, it'll just go forever.
Yeah. And the idea showing the weight that's driving this wheel, and because the balls retract in, I understand the concept of this quite well.
Yep.
Because because the balls are further out here, you got more leverage, and as they come in, they got less leverage, so the balls are here turning the wheel more than what the balls here are opposing it.
Here, that. You're young, strong.
So
you hold that again. Just hold it. Just that. Don't let it move. Now we're just creating a circle, right? We'll call this the centre. Then I'll get this.
Yep.
Okay.
Well, if you draw a line, I'll draw it straight to that point there, right?
Yep.
That's stationary. Right? All the rest is moving, right?
Yeah.
All the rest is moving. And I add weight there, and it stays there until it gets to there, right?
Yep.
So every time one of those hands on my clock reaches 2 o'clock, right, there's a weight put on it, right?
That's
and
right.
It stays on there until it reaches 4 o'clock. And it's left there. And when it's left there, gravity just lets it roll all the way back to the centre.
Mm-hmm.
When it gets to the centre, as that circle is half the size of the outside circle, right? It starts to pick that same ball up and move it up there, and because it never exceeds half the distance of that, 2 balls could be there at the same time, which only equal 1 here.
That's right.
And you never have any less than 2 balls on this at a time. As you've got 1 going on at 2, when it gets to 3, another one's going on. So, at the worst scenario, you've got 1 ball almost about to leave there. You've got another ball that's on there, and you've got 1 ball almost
just about
going on. Plus, you create momentum and power in the wheel itself.
Yeah.
Once the momentum of the wheel picks up, it in itself will pick a ball up and take it from the bottom to the top. Right?
Yep.
So by constantly adding the weight out there, you will always exceed what weight you have here.
That's right, because it's in a smaller area.
Now if you draw a line through there and through there, right, and you use a factor of 10, right, you would have 0, 5 and 10, right?
Yeah.
Now if you calibrated that up, right, you can imagine you start calibrating up here. That ball that's on here at 7 o'clock, we'll call 7 o'clock, he doesn't even know he's there yet because he's only moved out a fraction.
Yeah.
You know, this ball that's all the way back up here at 11, he's lost all his power. He's lost all his power. He's just pleased to get off again, right?
Yeah.
These couple out here, right? They're the ones that are putting a little bit of power on it. So but no matter how you calibrate it out, right, you will always exceed probably about 20% more weight out here than you will here.
So the force that's pushing down on the outer side, there's not as much force on the inside to counteract it.
That's right. And by instead of trying to pull it all the way up here to add the weight, you add the weight out here where you've got momentum, where you've got a leverage.
Yeah.
By adding weight up here, it does nothing until it gets out here, right? Yep. But by adding weight out there, it's like having a crowbar and shifting a rock, you know?
Is there anything critical, Chas, to the sizes and distances and ratios?
No, it doesn't make it, but it's important that you, when you make a thing like this, you've got to allow enough time for that ball to move from there into there, right? Into that space.
So
now, if you try and rotate it too fast, right? If you try and go too fast, the balls lose their weight. Yep. They become airborne.
Oh, okay.
It's like anything. They become centrifugally thrown out, right? And it won't work. So I would imagine that a wheel like that over there that you filmed before would never exceed any more than 4 or 5 RPM. Now that's at 5 RPM, right? At 5 RPM, right? That's what's 5 12s to 60, isn't it? That would be allowing 1 second for that to get to there, for that to get to there. 1 second, 1 and 2. Now I would say that would be a pretty fair, because if you come under that, you're asking the mechanism to do too much too quick. And to ask it to do it just using gravity alone is asking a bit, right? If it was mechanically operated, like valves, like pistons or points in a car, that's a wholly different thing. But to operate this just by gravity, you cannot expect it to go too fast. So to create the power, you build a wheel big enough, and strong enough and heavy enough. And once it starts rolling, it's like the tyre rolling down the street. If it was off a big truck and you stood in front of it, it would run over you. Right? Yep. If it was just off my little Datsun outside, I might get a bit of sponsorship for mentioning that word. No, only joking. But, you'd stop it with one hand, wouldn't you? Yeah. That's the same thing with the wheel. You build a wheel, but, things like that have got to be, when you're expecting everything to work without any mechanical devices at all. No springs, no magnets, it's just purely working on gravity.
And with the right engineering, you probably could engineer something that could do a few thousand RPM.
So just say you were given some endorsement in that. What would you do to improve this system, to make it how you wanted it, to optimise it? Well, you'd start with what?
Well, to start off with, you've got to build with a very substantial base, right? You have to have a base that's so rigid and so firm. You can't have any movement. You can't have any unnecessary movement. Everything, the balls are no problem. They'll always roll downhill. Yeah. That's no secret with gravity. It'll always roll that ball downhill. And once you put the ball on the outside of that wheel, it'll always push the wheel down, which in turn turns it around, right? But it's the mechanism in between to take the ball from A and put it to B without using any energy from the machine. And to take it from B to C without using any energy. Because every time you falter it's using a little bit of energy off the momentum of the wheel. And once you do that, then it becomes unstable. It starts to wander, roll, as you can see that one, it starts to sway. So the first thing is the whole inside of that has got to, the principle would remain the same. But the whole inside has got to be built out of materials and heavy enough so as, it's like leaning on that. It's not going to move, it's not going to move. Whereas that one, I'm afraid, just by transferring the weight of the balls going around and moving from one side to another, starts movement. And as you can see by those balls, they start to roll backwards and forwards where they should be sitting nice and stable. Now, there's engineers and professors around the world that could improve on this enormously. But the principle is so simple.
Yeah.
And why this hasn't been done 100 years ago, I don't know.
All the corporate suppression and that, they're scared of free power.
But they tell me that there's millions of dollars on offer for someone that can produce perpetual motion. I read that on the internet one night. Yeah. Some firm in America will give you 10 million or something like that. I don't know what they said, but I don't take much notice of that.
No.
Because 90% of it, you can put that there too, 90% of it is garbage. They're not interested in giving $1 away, let alone $1 million. But when I come up with this theory, by spending $50 and ringing up a company one day and asking them if they could get me a ball bearing, right? Everybody's telling me about that? I asked them if they could get me a ball bearing, and they said, we can get you a 50 mil ball bearing. I said, 50 mil? I said, what do they use it for? And there was a hesitation on the phone, and he said, well, it's a ball bearing. I said, oh.
They'd probably use it for...
Anyway, so I said, can you get me one? He said, just a minute. And he got back to me and he said, yes. He said, it'll cost you $50, Chas. I said, all right, get it for me. Shit. He said, I'll ring you when it's in. So I went over to pick it up, and he said, it weighs half a kilogram. Here, catch it. No, it won't land on your tail. It weighs half a kilogram. It's exactly 50 mil across, right? Now, he got that for me, and I come home with it, and I started playing with that ball, right? I had a theory that if you roll a ball, right, far enough, right, and it's got to be a round object, right? Now, what I done, I used aluminium like this, right? And up there in my lounge room, I had all sorts of devices set up. As a matter of fact, and I used to set that up. I might set that up, say, 4 inches above the floor, for argument's sake, you know, and see how far it had to roll before it had enough weight and pressure up, speed up, to lift it up 4 inches. Now, all of that's supposed to be impossible. But it's not impossible. You know, if it's sloping like that, by the Jesus, does she go? Does she go, you know? But you know, I used to experiment, and I had pieces of aluminium all calibrated out, you know, every 10 mil out. I had little devices on the floor that I used to lift this end up with, and I started at 1 metre or 2 metres, and I'd watch it. Now, you can see, as it goes down there, it picks up speed. Speed is power.
Yeah. Because you got the torque. The torque could probably stay about the same, but you got the speed there, which is increasing, and therefore the power is increasing.
Of course it does. It's as simple as that.
Yeah.
I didn't design that. It was just a theory I had. That all this crap about not being able to do this and not being able to do that is a load of hogwash. There must be ways of doing it. So I would spend hours playing with my steel ball, right? And I said to my son one day, he said, what the hell are you doing? And I told him. He said, where did you get that? And he'd never seen it. And I told him, and he said, $50. I said, I want 12 of them. He said, what for? I said, I've got a theory. I'm going to build a wheel. I'm going to use...
cheap with the
he said, that's $600 just to prove a point. Yes. I said, yeah. He said, why don't you use snooker balls? And I said, well, I don't know. He said, they're the same size. Right. I said, are they? Right. So I went and bought a set of snooker balls. Here's the box. Here's why I don't use the white one because it's a fraction smaller, isn't it? White one?
Yeah, I think.
And here's the one you break with. You know, the one that rolls back to you when you pot it mistakenly, right? You always get, it's a fraction smaller. So I went and the woman said to me, what are you going to do with that? I said, I'll make you famous one day, kiddo. But anyway, so that's how I come to buy those set of snooker balls. So $40 for a set of snooker balls to play around with, but it's a lot cheaper than $600 for 12 of these. Right?
And those things fall on the ground, Chas, aren't going to be kind shit.
No.
Those heavy half a kilo.
Oh, no. So, and of course all of this, this will work the same way, but you can imagine everything could have to be a hell of a lot stronger and be, that's level, because when the ball goes in there, it automatically picks up speed as it rolls out. You know what I mean? It's just like a little ramp. The theory of this is, when I come up with this theory after seeing diagrams on the internet and how this one had tried and how someone had spent millions and locked it away in vaults and how this one had tried, I was shifting and I thought, well, I don't know. There must be an easy way. So I thought if I made a wheel, and I tried to explain it to my son and my daughter one day, they both looked at me as if I had gone and I'd lost it, right? And I can understand that, but I said, the theory is that if you make a wheel and the middle of it becomes the working part of the wheel, the engine, right? The middle becomes the engine, but the middle never moves. The middle is controlled wholly and solely by gravity. The balls will roll one way or another and feed to the position to be taken them back to once again. And the one ball on the outside...
Yeah. Well, we just saw it do that, Chas. We just saw the three go in there and push that wheel. You weigh up the weight of that wheel.
Well, once you get the momentum up, right, it's amazing. It'll just... But as I say, the whole thing is
going to be more rigid, yeah.
And I done all this little bit of artistic work.
Yeah, look, he's got the nuclear family.
Yeah, that's right.
You've got to hand it to Chas, he's an artist. He's an artist.
Yeah, I know, but see,
we can't go giving children their free nuclear missiles either.
No. I was going to write lots of... I even had to see that piece of tip with the blue edge around it. Yep. I had it screwed here. I was going to paint it all up with a big flash car on it, and battery driven, I was going to do all sorts of things. But I thought, no, it's just that. But if I hadn't got it going the way I wanted it to go...
Yeah, plenty of time for that, mate.
Yeah, but I thought, when you said you were coming out, I want to show you this. I'm not ashamed of it.
That's a good device. Yeah.
It doesn't work as well as I would have liked to now have it working when you've got here, but...
Well, you can't do it on a shoestring budget.
No, but...
Shoestring budget will never get you...
While there's movement in there. But see, some of those university in America, the students would like to replica this or that or whatever. This would be ideal.
I think this one.
Then they would love this. Yeah. Some of those young students, I would love to have got a university in Australia and stuff. But those idiots that, I used to call them prominent citizens, right? Yeah. I referred to those 7 people on that board over there one day, prominent Australians, right? Yeah. Well, I now call them a couple of 4-letter words. Yeah. Very dumb Australians, right? Yeah. Very dumb. Not really, just very dumb Australians. Because not one of them at least said, how does it work, Chas? Yeah. I offered them all that. I said, I'll give it to you, I'll tell you. Not one of them said to me, how does it work?
Yeah, they're a bit too coy in...
coy, I told you, they're dumb, mate. They're dumb, right? Very dumb.
Absolutely.
A-section pulleys.
2 3/4
inch, yeah.
Yep.
Driving to a 5-inch.
Hang on. Pulley.
Yeah.
Yep. Driving to a
5-inch pulley.
Yep. 5-inch pulley.
And there's an 8-inch pulley. Driving to a 4-inch pulley.
9-inch pulley driven to a 9-inch.
A 4-inch, an 8-inch to a 4-inch.
Yep. Pulley, yep.
And a 9-inch driven to a 4.5 on the alternator.
4.5 on the alternator. So 9-inch pulley to a 4.5-inch on the alternator. Yeah. There you go, fellas. So did you say that Chas didn't want to give you anything away? There you go.
Now, the revs of this motor, according to the manufacturer, is 1430.
1430 revs.
And if you calculate that all out, you'll come at 3,146 on the alternator.
Which will be just over 50 hertz.
Yeah, but they told me that to drive it at least 0.3 or they told me always to drive it higher than the 3,000 revs.
Now we don't know what this weighs, but I'd say, but guessing probably about 4 kilos, 5
or
a bit more
than that.
About 7 kilos.
I would say that flywheel would weigh in the vicinity of
10 to 20 kilos.
Yeah, it'd be closer to 10 to 20.
So, say as a base, say it's more plausible to say 10 instead of 20, or 10. It's about 10 kilos.
10 kilo.
But that's how you can experiment from there.
And as I said in that letter, that my pulley ended up 72 inches thick, there's 6 layers of 12 mil custom board, right?
Yep. 6 layers of
12 mil custom board, right?
12 mil custom. Yep.
which is 72, right?
So that's a 2 3/4
That's a
inch
2
pulley.
3/4. Had a 3-inch pulley on there, then I changed it to a 4.5. But with the 4.5, because a lot of people say the bigger the pulley, the easier it is to spin.
Yeah.
Well, that is in one sense that's true, but in another sense, it doesn't allow for too much wind up. You know, you can overload the system with a big pulley because the belt itself requires that much traction, you know. It's hard to loosen that sort of... Whereas this, I can get that to spin in the belt, as you've seen it, without doing any damage to the motor. Well, not exactly doing damage, but I don't want the motor overloading while I'm trying to work it, build it up.
Yeah, that's a lot more simpler, Chaz.
We can use... What you can also do is you can have permanent tension on there and use a variable frequency drive.
That's another thing.
Yeah.
So you start off 1 hertz, 2 hertz, 3 hertz, up to 50 hertz.
There's better ways of doing it.
100
I said,
hertz.
there probably is.
We've got
200 hertz.
I'm only experimenting with this. And the easiest way for me to do it was have loose belts, like both of them are loose. But that doesn't mean to say, you know.
That's the clutch there.
And in this, I just wind it up. And this little thing here is purely a guide, so as it tries to come up straight, I put that plus a spring to put a bit of tension. Naturally, it'll want to tip over with once you get the tension on the pulleys, right?
Yeah.
So I just put that there so as it would lift up. So
that's not doing anything, Chaz.
That's doing nothing.
Maybe that'll add to some centrifugal force.
Oh, well, it probably adds
a little bit.